So looking at 2.57 from Chapter 2, AOPS Pre-Algebra, the challenge problems, two consecutive positive integers. So consecutive in a row. So for example, that would be 10 and 11. Okay? And how far apart are the squares of 10 or 11? Well, the squares of 10 or 11 are 100 to 121 are 21 apart. And that gets us back to the idea of how far are squares apart. So from a 10 square to an 11 square, it's 10 plus 10 plus 1. They're 21 apart. So from 10 to 11 squared is 21. Well, what's going to be 67 apart? Well, you think about it for a second and you say, well, 2n plus 1. So whatever the side is, twice that plus 1 is the difference. That's going to equal 67. And so you say, okay, well then 2n must be 66, n must be 33. So let's see if that's true. So what's 33 squared? So what's 33 squared? Well, let's think of two different ways to do it. So 33 squared, we could do it as 33 plus 3 and 33 minus 3 plus 9, the difference of squares method. That would be 36 times 30 plus 9. So 30 times 30 is 900, and 30 times 6 is 180, and then 9, 1089. Another way to do it would be to do the bow tie method, cross multiplication. So we could say 3 times 3 is 9, and then 9 nines and 9 nines is 18 nines. So remember the 1. 3 times 3, 900s plus 1, 1089. Well, what about 34 squared? So 34 squared we could do as 34 plus 4, 34 minus 4, plus 16, difference of squares method. So that gives us 38 times 30 plus 16. So 38 times 30. Again, we've got the 900 base plus 240 plus 16. So that looks like 1156. Well, how far is it from 1089 to 1156? Well, from what's the complement of 89? 11, right? So it takes us 11 to get to 1100. And then from there, 56 more, 56 plus 11, 67. Good morning. That's how you do that. So we went back, we found the squares are 2n plus 1 apart.